Alright guys, in this video I'm going to be reviewing with you some of the basic trig facts that you need to know to be successful in calculus. The first thing that we want to do is we want to be familiar with the unit circle. So without any further ado, let's go ahead and get started. So what you're going to need to know or have memorized from your unit circle are the radians, which are the angle measures. And you also need to have the coordinates measured, or remembered, I mean. And I'm also going to have you guys memorize the tangent values. So we're going to be studying all three of those here. So let's begin here. Let's start with the radians. So now the radians start here at 0 radians, and after that it's going to be pi over 6. And then pi over 4, and then pi over 3. And then up here we have pi over 2. Okay? Now, before I share with you guys the rest of them, I want to talk about the symmetry of this thing. So, for instance, this point right here is pi over 6. Well, the one that's directly across from it over here is also a pi over 6. And so we'll call that pi over 6. But there's going to be a number here, and I'll talk about how to get that in a minute. All right? But that's not all there is to the symmetry of the circle. There's also, if this is pi over 6, then the one directly across from it down here is also a pi over 6. So basically, you have a pi over 6 here. You have a pi over 6 here also, by the way. In here. So you have these 4 spots that are all pi over 6s, and they're symmetrical to each other. Okay? But these 3 here, they're going to have a number on the top, and I'll tell you how you can get those. Well, the same thing applies to all the other points. So, like for instance, this is a pi over 4, so this is a pi over 4 also. This is a pi over 3, so this is a pi over 3. So you've got some symmetry there. So that's how one way you kind of help yourself memorize that. So let's go ahead and do the second quadrant here. So if this is pi over 3, then the one directly across from it, symmetrical to it, is also a pi over 3. And then this is a pi over 4, and this is a pi over 6. Now, as I said though, there's going to be some numbers here. All right. So here's how you can find those numbers. In this quadrant, you're going to subtract 1 from the denominator. So what's 1 less than 3? That's 2, right? That's going to be going up there. What's 1 less than 4? That's 3, so that's what goes up there. What's 1 less than 6? That's 5, so that's what goes up there. So in this second quadrant over here, these numbers are all have a numerator that's 1 less than the denominator. Okay? Now this is a pi, so that's that radian. But let's go ahead and continue the symmetry here. This will be a pi over 6, this will be a pi over 4, and this will be a pi over 3. Now the rule for this quadrant is different from the second quadrant. For this one, you add 1 to the denominator. So for instance, since this is 6, if you add 1 to that, you get 7. So that's 7 pi over 6. For this one, if you add 1 to 4, you get 5. So that's 5 pi over 4. And so on. If you add 1 to this, you get 4. So it's 4 pi over 3. So notice that the denominators, you can find all the denominators, they're all the same just by symmetry, but the numerators are different. So in this quadrant, the numerators are subtract 1 from the denominator. In this one, the numerators are add 1 to the denominator. Now this bottom one down here, you just got to memorize it, is 3 pi over 2. All right, let's do the last quadrant here. This last quadrant is not as friendly as the others, but this is a pi over 3, this is a pi over 4, and this is a pi over 6. Now once again, we need to find our numerators here, but it's not add 1, it's not subtract 1, we're just going to say it's prime. Primes. What do I mean by that? Well, we left off on a 3, right? So what's the next prime number after 3? It's 5. What's the next prime number after that? 7. What's the next prime number after that? 11. Okay, so how do we get the denominators? The denominators you can get because of the symmetry. But the numerators, these numerators are subtract 1 from the denominator. These ones are add 1 to the denominator. These ones are primes. Now, I didn't give you any cool memory tricks for these guys. But those ones people tend to remember pretty well anyway. But there you go. So that's the radians. So you guys should be able to recreate this on your own. Now, you have it on your notes. You're thinking, well, I don't need to memorize this. I'll just look at it when I need to. You can't look at it. There's going to be times whenever you're not allowed to use notes. So you do need to have that memorized. So those little memory tricks I was giving you along the way, you're going to want to incorporate those. Okay? All right. So now those are the radians. Now let's go ahead and let's take a look at the next part. Let's do the coordinates on the unit circle. All right, the coordinates. Let's start off with the left and the right, and the top and the bottom. Those are kind of the easiest ones. On the unit circle, this length is 1. It's like a circle, and the radius is always 1. And so the x value of this point would be 1. And since the y value is right on the on the x-axis, that would be 0. Okay? For this one here, this point is up 1, but it's left none. So that one has a coordinate of 0, 1. This one is left 1, up none. This one is over none, but down 1. So there's your 4 coordinates for the top, left, right, and bottom. Now let's get the other ones. Now once again, there is symmetry going on here. And in my opinion, this one's a little bit easier to figure out. All right, guys. So for the coordinates, first of all, I think one thing that's kind of nice to understand when we're trying to go through and memorize this is that the denominator of any point on the unit circle is always a 2. Unless it's one of the 4 that I already gave you. Okay? But now the tops have square roots on them. Some don't, but I'll show you why in a minute. But for now, let's just put square roots on all of them. Now, what we want to do is we want to figure out what goes in these spots, and there's a nice way to memorize that. You can just use your hand. So if you put your hand here, you can put your pinky on the y-axis, your ring finger on the next line, your middle finger on the middle line, your index finger on the next line, and then your thumb on the x-axis. And if you want to find out what the numerators are for any point, like let's do this one first, take that finger that is for that point and put it down. However many fingers are on the left, 1, 2, 3, that's your numerator there. However many fingers are on the right, that's your numerator there. So let's do that again for the next one. For this one, I want you to take down this finger. So there's 2 fingers on the left, 2 fingers on the right. Let's do the last one, that guy. Put this finger down, 1 finger on the left, 3 fingers on the right. Okay, now, all of those are going to stay the same except for 2 of them. The square root of 1 is just 1, so why not just put 1 then instead? So that's the only one that's really different, but there you go. Okay, so that's, now once you have those 3, the rest of them are pretty simple to get. So the reason the other ones are easy to get is because once again we have symmetry. If whatever this point is, the one directly across from it here, and the one directly across from it here, and also here, will all be exactly the same numbers. The only difference will be their signs. So for instance, let's go ahead and put them all in there. So this one's radical 3 over 2. This one's 1/2. This one's also radical 3 over 2. And this one's 1/2. This one's radical 3 over 2. and 1/2. But like I said, the only difference is going to be in the signs. Since you're in the second quadrant over here, the x value is to the left, so it's negative, but the y value is still above the x-axis, so that would be positive. For this one here, we have the y value is negative because it's under the x-axis, and the x value is negative. And then for the last one over here, the x value is positive, but the y value is negative. Okay? And we're just going to continue doing that with the rest of these points. Okay? So this point will also be the same numbers here, here, and here. All those middle quadrant ones will be radical 2 over 2's, but you just got to get those signs correct. And then we have the last one here. And once again, using the principles of symmetry, we're just going to copy this point everywhere else and make sure that we use the right sign. All right, so there you guys go. So those are the coordinates. So I've shown you what the radians are. I've also helped you memorize, giving you some tricks to help memorize what the radians are. I have also shown you the coordinates now and gave you some tricks to help you memorize the coordinates. We have one more thing that you need to make sure that you are familiar with, and that's the tangent values. So we've done radians. Those are the angle measures. We've done the coordinates. Those are the point values. And the last one we're going to talk about is the tangent values. Now, if you guys had Mr. McMillan last year, I don't know if he had you guys memorize any of this stuff or if he just gave you the sheet and let you use it. Some teachers ask you to memorize it and some don't. Because in Trig Pre-Cal, it's not that big of a deal. But in Calculus AP, it's very important that you have it memorized. So if you haven't memorized it yet, now is the time. Okay. So tangent values we need to memorize also. Tangent is going to look like this: 0, radical 3 over 3, 1, radical 3, undefined. So once again, we're going to get that first quadrant down. Now, unfortunately, I don't have any great memorization tricks for you on this one. This one, you just kind of have to, push yourself through to memorize it. But there's our first quadrant. But the symmetry applies once again. So for instance, if there's a U on the top, then there's a U on the bottom. U means undefined. Tangent doesn't exist up there at that point. If there's a 0 on the right, there's a 0 on the left. And this will be radical 3, just like the one across from it. This will be 1, and this will be radical 3. But the only difference is these are negatives. Okay. Same thing here. Symmetry applies. Interestingly, these ones are positives. The reason why, if you're interested in knowing why, is because tangent is the y value divided by the x. So since in this quadrant, both the x and the y are negative, it cancels out the negative, and therefore it ends up being positive. Then we have our last quadrant here. So there's less to memorize with tangent values, thankfully. What you do want to know is that all the tangents in this quadrant and all the tangents in this quadrant are negatives. The other two quadrants are positives. But other than that, it's the same 4 numbers repeated over and over again there. All right? So those are your tangent values. So you need to know what the unit circle is, but you also need to have it memorized. So take the time to memorize it. I've given you some tricks. I would encourage you to just draw a unit circle and practice timing yourself and filling it out. The faster you can fill it out, the better you'll be at doing your trig stuff. All right, guys, so we're going to solve some problems now. Now, there's the unit circle over there on the right. It's got the radians on there. It's got the coordinates, and then the tangent values are in green. So we'll look at that as we go. Something important you guys need to be aware of is that the x-coordinate is cosine, the y-coordinate is sine. So let's keep that in mind for now. The x-coordinate is cosine, and the y-coordinate is sine. So take a look at this. So since it's cosine, we're looking for x. And so we're going to find that radian on the unit circle, 7 pi over 4, which is right there. And then our answer is going to be the x coordinate for that point. So it's radical 2 over 2. Okay, so since it was cosine, we were looking for x, and then we found the angle and picked the x value at that point. All right, let's go ahead and take a look at another example. Sine of 7 pi over 4. Now, sine is the y value, and we have the same angle that we're looking at, so we're still at 7 pi over 4, and the y value is negative radical 2 over 2. So that's the answer there. Sine of 7 pi over 4 is radical 2 over 2. All right, let's take a look at one more, and then I'll let you guys practice. Tangent of pi over 2. So now tangent is the green, these numbers here, the green ones. So I can't really say it's x, I can't really say it's y, it's just those green numbers. So I need to find pi over 2. Here's pi over 2, and the green number that goes with that is undefined. In other words, there's no answer to this. This one is undefined. Okay, so that's how you can evaluate trig equations. Let's go ahead and have you guys try some of these real quick. I want you guys to do numbers 4, 5, and 6. Pause the video here, work them out, and then when you're done, you can unpause the video and see if you got them right. All right, guys, so there's the answers to 4, 5, and 6. I'm going to move on to the next part of this now. We're going to talk about these three now: cosecant, secant, and cotangent. Now, what's interesting about those ones is that they are reciprocals of the other ones. So, what do I mean by that? Cotangent is the reciprocal of tangent, secant is the reciprocal of x, and cosecant is the reciprocal of y. So, I'm looking for cosecant, which is the reciprocal of y. So, let's find our angle, 3 pi over 2. Now let's find the y value for that point, negative 1. Y equals negative 1. Now, you want to think of that as a fraction, so I'm going to put it over 1. What's the reciprocal of y? Well, if you take this and flip it over, you get the same thing. So it's still negative 1. So there's my final answer. It's negative 1. So it's just like finding the sign. In other words, you look for the y value, but the difference is you have to take the reciprocal of it. Let's take a look at another example. Cotangent. All right, cotangent of 3 pi over 2. All right, so let's find 3 pi over 2. And we want the cotangent value. So that's going to be the reciprocal of tangent. All right, the reciprocal of tangent. Well, the tangent value there is undefined. So you might be thinking, okay, well, there's no such thing as a reciprocal of something undefined. But there is. The answer is going to be 0. Now, let me explain why. The reason why is because tangent is y over x. So tangent is y over x. My y value at that point is negative 1 and the x value is 0. The reason it's undefined is because you're not allowed to have 0 in the denominator. But if I take the reciprocal of that, it becomes 0 over negative 1. And that does exist. The answer is 0. So anytime tangent is undefined, cotangent will be 0. Likewise, anytime tangent is 0, cotangent will be undefined. So there's that one. Let's look at one more. Secant. I'm going to change this one. All right, so let's do secant. Now, secant is the reciprocal of cosine. So I want to find 5 pi over 4. There it is. Oh, I should have said the reciprocal of x, not cosine. So I want to find my x value, which is negative radical 2 over 2. So x is equal to negative radical 2 over 2. So the reciprocal of that is going to be 2 over radical 2 over 2. The negative stays. And so there's that answer. Now, it would be nice if we could just leave it that way, but you guys may know and recall that we don't leave radicals on the bottom of fractions. So we get those out of there by multiplying the top and the bottom by the square root of 2. So we have negative 2 radical 2 on the top, and a radical 2 times a radical 2 is just 2. And since 2 divided by 2 is 1, then we just have negative radical 2 as our final answer. Okay? So the idea there, the big ideas, takeaways here is that cotangent is the reciprocal of tangent, secant is the reciprocal of x, cosecant is the reciprocal of y. Some other things that you want to keep in mind is that if you have a square root in the bottom, you've got to multiply the top and the bottom by the square root. And the other weird thing to keep in mind is that if you have an undefined, then the reciprocal of that will be 0. And if you have a 0, the reciprocal of that will be undefined. All right, so let's go ahead and have you guys try a couple of these. Why don't you guys try 10, 11, and 12? Pause the video here, and when you pause it, I'll have the answers up for you. All right, so there's those. You guys can check your work. So I'll work these out a little bit because this is probably a little bit more challenging than last set. So 7 pi over 4 for the first one is right here. Since it's secant, we want the reciprocal of x. So I'm going to take radical 2 over 2 and I'm going to flip it over. And then I'm going to multiply the top and the bottom by the square root of 2, which gives me 2 radical 2 over 2. And then when you reduce the 2's, you get that. Let's do number 11. Pi over 6 is right here. We want cotangent, which is the reciprocal of the tangent value. My tangent value is radical 3 over 3. So the reciprocal of that is 3 over radical 3. So once again, I'm going to multiply the top and the bottom by radical 3. The top will become 3 radical 3. The bottom will be 3. Those cancel, and we're left with radical 3. Number 12, we're looking for cosecant of pi over 3. Here's pi over 3. Cosecant is the reciprocal of the y value, or the sine value, and that's radical 3 over 2. So if I take that and I flip it over, it looks like this, but once again, we don't like that square root in the bottom, so we multiply the top and the bottom by a square root of 3. And on this one, nothing reduces, so we just leave it like that. All right? So that's evaluating. So when you have a trig function, you put your angle here, which is some radian, like that's a radian, and the answer will be an x-coordinate, a y-coordinate, or like a tangent value or something like that. Okay? Now, for the problems that we just got through doing, 1 through 12. On all of these, I gave you an angle and I asked for the coordinate. But we could do it differently. I could give you the coordinate and ask what the angle is, and that's next. So let's go ahead and take a look at some problems that do that now. So in this case, cosine of theta equals -1. So what angle, or you could just say radian if that helps you understand what I'm looking for. What radian has an x value of -1? Okay, so what angle has an x value of -1? Well, let's look at our unit circle, and let's find all the places where there's an x value that's a -1. I only see one, and it's right here. And the angle that goes with that, or the radian, is pi. So the answer is pi. Let's take a look at another example here, sine. All right, so what angle? Now that's sine, so that has a y value. So what angle has a y value of negative radical 3 over 2? Take a look at your unit circle, see if you can find it. I see two of them. There's one here, and there's also one here. Oftentimes when you're finding the angle, there will be two answers. Not always, like the last one didn't, but a lot of times there will be. So there's two angles that have that, 4 pi over 3 and 5 pi over 3. Okay, we'll do one more before we practice a little bit. What angle has a tan value of radical 3 over 3? I see one here, and I see one here. So the angles that go with those tangent values are pi over 6 and 7 pi over 6. All right, so here's 3 problems for you guys to try. Go ahead and pause the video here. See if you guys can find the angles for each of these problems. When you unpause it, I will have the solutions up for you. All right, so there are the answers. I'll let you guys go ahead and check your work. And we're going to go ahead and move on to our last bit for this lesson here. All right, once again, we're going to look at the secant and the cosecants and the cotangents. Those are always a little bit weirder because you have to do the reciprocals. All right. So what angle has a reciprocal x value of 2? Okay. Now, another way that we could word that is, what angle has an x value of 1/2? Okay, so instead of saying what angle has a reciprocal x value of 2, we'll just take the reciprocal of 2 and word it this way. It might be a little bit easier. So now I'm looking for where x equals 1/2. Well, that would be here, and it would also be here. And so those angles are pi over 3 and 5 pi over 3. So the difference with these 3 problems down here, cotangent, secant, and cosecant, is you're not looking for the x value anymore. You have to take the reciprocal of the number they give you, and that's the value you're looking for. All right, let's do another one. I'm going to change that real quick. All right, so what angle, now this is y, and this is my number. So I'm going to say has a y value of the reciprocal of that, which is 1 over radical 2. Okay? Since it's a cosecant, we're looking for the reciprocal. And the reciprocal of radical 2 is 1 over 2. So we're looking for a y value that has that. Now, you guys will notice, if you stare at this table long enough, you're going to see there's nothing like that up there. Well, that's because this isn't in the right form. We have to fix it. We're going to multiply the top and the bottom by radical 2. And now it's in the right form. So which angle has a y value of radical 2 over 2? There's one here, and there's also one here. And so the angles are pi over 4 and 3 pi over 4. All right. Let's go ahead and take a look at another one here. Okay, so what angle? Now we want we're looking for the reciprocal of this number for tangent. So remember, cotangent is the reciprocal of the tangent value. So I want the reciprocal of this number. So what angle has a tangent value What's the reciprocal of 1? Well, 1 is 1 over 1. If you flip it over, you get 1 over 1, so it's still 1. The reciprocal of 1 is 1. So what angle has a tangent value of 1? 1 here, 1 here. So that's 5 pi over 4 and pi over 4. All right, let's go ahead and take a look at one more before I let you guys practice a little bit. Actually, I think this is your guys' set. I think we already did some. So go ahead and try these 3 problems, and when you unpause it, we will discuss the results. All right, so for number 22, we're looking for what angle has a tangent value that's a reciprocal of that. So first of all, let's fix this. I need to flip it over. Now I need to get the square root out of there and reduce. So what angle has a tangent value of radical 3 over 3? I'm sorry, just radical 3. So that would be this one and this one. So that's 4 pi over 3 and also pi over 3. Number 23. So what angle has a y value that is the reciprocal of this? Once again, we got to fix it. So what angle has a y value of negative radical 2 over 2? That would be here and here. So 7 pi over 4 and 5 pi over 4. Last one. What angle has an x value which is the reciprocal of that? Now we just did that one in the last problem. That's the same thing. If you flip it over, you get the same thing. So, but this time we're looking for the x value. So which angle has an x value of negative radical 2 over 2? Well, that would be this one and this one. And so those angles are 3 pi over 4 and 5 pi over 4. So these are the 3 skills that you guys need to be able to do trig in calculus. You need to know your unit circle. I gave you some strategies for memorizing that. You also need to know how to do problems like this, where I give you the angle and I ask you what's the coordinate. You also need to know how to do problems like these, where I give you the coordinate and I ask for the angle. And for all of those types of questions, you need that unit circle. So hopefully that was helpful, and we'll see you guys later. We'll be doing some trig sometime next week. Till then, have a good one.